Hey guys, I hope you're having a great vacation so far. Here is the first video for the new content that I need you to do over break. There'll be two actual assignments. The first one I already put up on Edmodo, and I'll write the page numbers and numbers later in the video. But let me just give you the basic idea. The basic idea is simply ABC. Okay, so it's just the alphabet, no big deal. I'm sure we all know the alphabet. Except this alphabet stands for area between curves. Okay, so suppose we have a couple of curves or functions, whatever you want to call them. Say we have, like y equals x squared plus 1, y equals x, and we want to find the area between these two curves. Okay, let's say between x equals 0, from x equals 0 to x equals, let's go with just 1, something simple. Okay. So between 0 and 1, we want the area between these two curves. So it's a really good idea to get a picture. And you could graph it if you want, on your calculators, but these aren't so complicated. Let's just get a picture here. X squared plus 1 would basically, well, x squared is just this, right? So plus 1 would be here. So y equals x squared plus 1 is here. Y equals x squared plus 1. And then y equals x is just a straight line going this way, right? So basically something like this. So here's y equals x. And we want the area between these two curves from 0 to 1. So let's just say this is 1. So it's essentially here, right? Basically this little region right inside here. That's what we want. All right. So the main idea here is if this y equals x wasn't even here, and I asked you to find the area under x squared plus 1, but above the x-axis, you wouldn't have any problems with that. You would just integrate from 0 to 1, and that would really be this whole thing. Right? The whole blue in here would be x squared plus 1. The only difference is we don't want the whole thing. We want to get rid of this. We just want this one. So what we would do is we would subtract out the area underneath y equals x from 0 to 1. And what's left over would be the red region here. So again, the area under x squared plus 1 would be this entire lightly shaded blue. Take away the stronger blue lines here, and what's left should be the red region. So that's all we're doing. We're essentially doing two integral problems in one shot. So we're going to integrate from 0 to 1 the area under x squared plus 1, and we're going to subtract the area under y equals x with respect to x. That's really all the main idea. It's essentially, if we're doing it with respect to the x-axis, which we are, because we're going, underneath x squared plus 1, underneath y equals x, it's essentially the area under the top function minus the area under the bottom function. Could you separate these two and do them individually? Absolutely. It really doesn't matter, actually. But this is the main idea. So then you'd solve this, 0 to 1, x squared minus x plus 1. I'll just do this one by hand because it's not that complicated. But you could do it in the calculator too. But I think we should be able to do it both ways. So x cubed over 3 minus x squared over 2 plus x between 0 and 1. So that's going to be 1/3 minus 1/2 plus 1 minus a whole bunch of zeros. So let's see, that's going to be 2/6 minus 3/6 plus 6/6. What was that, 5/6? Something like that. And that's basically it. Okay, so main idea, area between curves, is you take the area under the top curve and subtract out the area under the bottom curve from whatever the intervals are that they give you, or sometimes you have to figure them out, depends on the problem, and then just integrate. Okay, so it's still basic integration, it's still basic area, and it's just a matter of adding in one more little level to it. Okay, so there's your first example, and let's do another one. All right, let's see. Oops. All right, suppose we have y equals x squared and y equals 2x minus x squared, and that's all they give you. They just say find the area between these two curves. Well, first of all, again, if this was a non-calculator question, you really should be able to graph those. But if you need to use the calculator to get a good picture, that's fine. But I'll just draw it because it's not that bad. X squared, of course, is this one. No big deal. 2x minus x squared, if you think about it, just on its own, It's really this, right? So you could find the roots that way. So we know it crosses at 0, and we know it crosses at 2. And it's essentially a parabola going this way, right? So something like this, maybe. Okay, and then the question is, we don't know that point right now, right? So if we're gonna do the area below the top curve, which would be here, and subtract out, let me just make that, subtract out this area to get the red region, just like before, well, we need to know what this point is. So if we're doing this by hand, we would just literally set these equal to each other and solve, right? We're trying to find the point of intersection of these two curves. So x squared equals 2x minus x squared, when 2x squared minus 2x equals 0. Take out a 2x. So it looks like they cross at 0, which we knew. That was kind of obvious. And x equals 1. And when x equals 1, y equals 1, so it looks like 1, 1 is our point of intersection. Okay? Again, at this stage, I think this one is doable by hand. Is it a huge deal if you use the calculator to figure that out? No, it's not a huge deal. But, I mean, that's stuff we should be able to do. So just like before, the only difference is here, I didn't give you the points of intersection. When you set up your integral, we're going to go from 0, x equals 0, to x equals 1. And we're going to do top minus bottom. So the top one is actually this one here, and the bottom one is actually this one. So it's going to be 2x minus x squared minus x squared with respect to x. Now, if you mess that up and you accidentally go bottom minus top, all that's going to happen is you're going to get a negative answer, which does not make any sense in the context of this kind of problem, because we're actually looking for the area between the two curves. You're not going to have a negative area between two curves. Even if these two curves were below the x-axis, right? Remember how we talked about when a graph goes below, there's an area value that has a negative, it has a negative sign. That's not going to happen here because you're actually subtracting the two areas to get a net area, which is always going to be positive. Okay? So let's clean this up. 0 to 1. This is going to be 2x minus 2x squared. So just like before, this one's not so complicated. X squared. This is x squared over 2, but it's times 2, so it's just x squared minus 2x cubed over 3 from 0 to 1, which is 1 minus 2/3. Does that sound right? Which, of course, is 1/3. So the area between these two curves is just 1/3 square units, whatever. Again, if they don't give us units, we don't give them units. And that's the basic idea. Okay, I'm going to stop the video here. Then I think I'll do a couple more examples, one with the calculator, and then one I think where we go using the y-axis. Okay, but this is probably enough to get you started through most of the homework. What were the numbers again? Hang on, let me get it for you. Let's see, I just put it up too. Where is it? Homework. There it is. Homework number 1 is pages 380 to 381, numbers 1 through 21, and 26 through 28. When I get home tomorrow, we're going to New York for the day, so when I get home, I'll post the answers to the evens. But you should at least be able to do the odds for now, and then I'll post those later. Okay? All right. See you later. Let me know if you have any questions, and I hope you guys are having a good break. See ya.